If two triangles are similar, then their corresponding sides are not proportional. P conditional to negation Q. Write down the values. What is P? P is nothing but true. Disjunction. R is nothing but false. Conjunction. Q is nothing but true. Negation of P, disjunction, Q, conjunction, negation, R is a false statement. Hello dear students, welcome to this session of Mathematical and Statistical Computing. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding writing the truth table for the connectives like conjunction, disjunction, conditional, biconditional and negation. So, in this session, I am going to discuss regarding few examples regarding those logical connectives like conjunction, disjunction, conditional, biconditional and negation. So, here if P and Q are any two compound propositions, then the connectives which we are going to use is AND. AND means P conjunction Q. AND is called the conjunction. Next R, ORR, that is P disjunction Q. Right. Then conditional statement, that is conditional means if then. For if then we are using P conditional to Q. Right. For biconditional if and only if. So the symbolic representation is B biconditional to Q. P biconditional to Q. And for negation it is not. That is nothing but not P. Negation of P is not P. So conjunction, disjunction, conditional, biconditional and negation. So these are the connectives. Based on this, let us discuss some problems related to this. Now, symbolize the following propositions. So these are all 2-marker questions. So you may expect this for 2 marks. Symbolize. So the statement is given, verbal statement is given. We have to represent in the symbolic form. So what is given here? 2 plus 5 is equal to 6. Consider this as P. R, all integers are rational, this is Q. So what is P here? P is nothing but 2 plus 5 is equal to 6. Either it may be true or false, doesn't matter. Just what is the statement given here? 2 plus 5 is equal to 6. And what is Q? Q is nothing but all integers. All integers are rationals. All integers are rational. So this is P. And this is Q. Now what is the connective given here is R. So what is R? R for R, what is the connective we are going to use? Disjunction. Disjunction is used for R. So here this can be written as P disjunction Q. So therefore the answer for this is the symbolic representation, the symbolized form of this, the symbolic representation of 2 plus 5 is equal to 6 or all integers are rationals is denoted as P disjunction Q. That's it. So if you write this much, you will get 2 marks. Now let us take one more example. If two triangles are similar, then their corresponding sides are not proportional. So here what is given? This is P. P means two triangles are similar, then their corresponding side, this is Q. So this statement is started with if and then connected with then, right? So this is started with if and then this statement is connected by the connective then, if then. So if then is nothing but the conditional statement P conditional to Q means if then. So therefore here the answer for this is if two triangles are similar means P conditional to Q. This is the symbolic representation. What is P? Two triangles are similar. What is Q? Their corresponding sides are proportional. So this is P. P means nothing but two triangles are similar. What is Q? This part. Their corresponding sides are not proportional. Not proportional. So that means for here it is not proportional. We are going to write negation of Q. So therefore the answer for this is the given statement is P conditional to negation Q. So P conditional to negation Q. See, P conditional to Q means if two triangles are similar, then their corresponding sides are proportional. Here it is given not proportional. So not proportional is nothing but negation of Q. So the final answer for this is P conditional to negation Q. P conditional to negation Q means if two triangles are similar, then their corresponding sides are not proportional. P conditional to negation Q. Suppose if the sides, if they have not given this word not, means if two triangles are similar, then corresponding sides are proportional, means we can write P conditional to Q. Since it is not, means negation, P conditional to negation Q. Followed. This is how we are going to write the symbolic form for this given proposition. Now let us move on to a similar problem. So if a quadrilateral is a square, then it's a rectangle. This is very simple. Here what it started with if. So a square, yes, a quadrilateral is a square. This is P. Then it is a rectangle. This is a rectangle. This is Q. That means this is started with if, then connected with then. So therefore P conditional to Q. If then, here it is if then. If then means that is nothing but P conditional to Q. P conditional to Q means if a quadrilateral is a square, then it is a rectangle. Right. In the previous problem, they have given not. So here not is given. So straight away you can write P conditional to Q. Okay. Now move on to the next problem. 3x is equal to 9 and x is less than 7. Here they have used the connective and. So and is used for conjunction. Conjunction is represented by the connective and. So here let us call it as P. What is P? 3x is equal to 9. And what is Q? Q is nothing but x is less than 7. These two are connected. This is P and Q. These two are connected by and. So therefore the symbolic representation of this is P conjunction Q. P conjunction Q. That means 3x is equal to 9 and x is less than 7. Now move on to the next problem. If two numbers are equal, then their squares are not equal. If two numbers are equal, so for P, two numbers are equal. Two numbers are equal and Q, then their squares are not equal. If two numbers are equal, then their squares are not equal. That is nothing but this. Two numbers are equal P, their squares are not equal. This is Q. So therefore here the conditional statement is given connected with a negative, that is not negation. So therefore if two numbers are equal, then their squares are not equal, means P conditional to negation Q. P conditional to negation. Move on to the next problem. So what is the next problem? Here if oxygen is a gas, then gold is a compound. Again this is a conditional statement. That is, this is P, oxygen is gas, gold is a compound, this is Q. So these two are connected by if then. So therefore it is nothing but a conditional statement. So what is P here? P is nothing but oxygen. Oxygen is a gas. Oxygen is a gas. And what is Q? Q is nothing but gold is a compound. So these are connected by conditional. So therefore the symbolic representation of this statement is P conditional to Q. P conditional to Q. So if then nothing but P conditional to Q. Now hope you got an idea how to represent the given statement in the symbolic form. Now let us move on to the next type of problems. In the second set, these are also important for 2 marks. If the truth values of the propositions P, Q, R are given, so the truth value of P is given as T, the truth value of Q is given as T, and the truth value of R is given as F. So P is true, Q is true, R is false respectively. Then the truth values for the following compound proposition. So what is given? The first one is P conditional to Q conjunction R. So what is given? P conditional to Q conjunction or. So that is nothing but, what is P? P is nothing but true conditional to this part. Q, what is Q? True conjunction F or is F. That means in case of conjunction, true and false is false. In case of conjunction, true and true is true. In all cases, it is false. So true and false is false. So this is nothing but false. Again, this is conditional statement. In case of conditional, true and false is again false. So this is equal to false. Right. So since the reason is in case of conjunction, true and false is false, and similarly in case of conditional, true conditional to false is again a false. So therefore the entire statement is false. Very important for 2 marks. So you may expect this type of problem for 2 marks. So here what is to find? P conditional to Q conjunction or. P is nothing but true, conditional to Q is true, conjunction or is false. So you just keep true as it is, conditional to Q conjunction or, true and false is false. Again, conditional true and false is equal to false. The entire statement is false. Now move on to the second problem. If the truth values of the proposition P, Q are T, T and F. So the truth value for P is true and the truth value for Q is also true, and for R it is F, right? These are the truth values. Now what is to find? The truth value for P disjunction or conjunction Q. So here it is P disjunction or conjunction Q. Write down the values. What is P? P is nothing but true, disjunction, R is nothing but false, conjunction Q is nothing but true. Since you know what is the disjunction of true and false, so true, false, disjunction is always true. You know, in case of disjunction, false and false is false. In all cases, it is true. So true disjunction F is true. So this part is true. True conjunction true. So in case of conjunction, true and true is true. So this is equal to true, because write the reason, true conjunction true is equal to true. So true and true is equal to true. So the given statement is true. That's it. Okay. Now move on to one more problem. Let us take one more example. Same. If the truth values of the proposition they are just changed here. So the truth values of the proposition P is T, for Q it is F, for R it is T respectively. Then the truth values for the compound proposition. Now, so what is given here? P is given, P is true, then Q is given. So we have to find negation of Q. So what is negation of Q? Negation of Q is nothing but true, because what is Q here? False. Negation of false is true. So here this can be written as P conjunction negation Q conditional to R. So what is P given? P is nothing but true, conjunction negation of Q. Negation of Q is nothing but again it is true, conditional to R. What is R? R is equal to true. Now what is this? Conjunction true and true is equal to true. In case of conjunction, true and true is true, conditional to true. So what is true and true in case of conditional? True and true is again true. So in case of conditional, true and false is false. In all other cases it is true. So therefore true conditional to true is also true, right? Now the statement is true. Now move on to the next problem. If the truth values are again same, P, for P it is T, for Q it is false, for R it is true. So T, F and T are given, then the truth value for this. So very simple concept here. So here just find out P conditional to Q conditional to R. What is the truth value for P they are given? That is T conditional to Q. What is Q? Q is false, conditional to R. R is true. So this is equal to T as it is. Now what is false conditional to true? So in case of conditional, true and false is false. In other cases it is true. So since F conditional to T is equal to T, this is T. What is the conditional of T and T? T and T is equal to T. T conditional to T is T. Followed. See here, conditional of false and true is true. True and true is again true. So that's it. So hence the given statement is true. Move on to the next problem. This is a different problem. If negation P, disjunction Q, conjunction negation R is false proposition, then find the truth values of P, Q and R. So this statement is false. That means what is given? Given negation of P, disjunction Q, conjunction negation R is a false statement. For false in conjunction, false and false is false. So that means this is false, conjunction false is equal to false. That means what you say here, therefore negation of P, disjunction Q is false and negation of R is equal to false, means therefore negation of R is false, means therefore R is equal to true, right? So here R is equal to true, one value we got. Now the second part, negation of P, disjunction Q is false. In case of disjunction, if it is F and F, then it is F. In all cases it is true. So this is false, means this must be false, disjunction false is equal to false, right? So because F and F is F, in case of disjunction, false and false is false, in all cases it is true. So if this statement is false, means first statement is false, second statement is also false. So from this you will get F is equal, Q is equal to false. Negation of P is equal to F, means therefore P is equal to T. So therefore what you say, P is equal to true, Q is equal to false and R is equal to true. So therefore the final answer for this is therefore. So the truth value for P is true, Q is equal to false and R is equal to T. So TFT is the truth value, right? This is how we are going to solve this problem. You may expect this also for 2 marks, okay? Now move on to the similar problem. Negate the following proposition. So here negation of the given statement, P conditional to Q conjunction R. This is very important problem. So negation of this, negation of P conditional to Q conjunction R, right? Now for this there is one rule. Since negation of P conditional to Q is logically equivalent to negation of P conditional to Q is logically equivalent to P conjunction negation Q. So this is a rule, that is negation of, if you negate P conditional to Q, you will get P conjunction negation Q. So here the negation of this implies negation of P conditional to Q means P, that is P conjunction negation of this Q conjunction R, right? So P conditional to Q negation is equal to P conjunction negation Q. P as it is and conjunction of negation of Q conjunction R, okay? Now using De Morgan's law, this can be written as P conjunction negation of this Q conjunction R is nothing but negation of Q, conjunction becomes disjunction negation of R. So negation of Q conjunction R becomes negation Q disjunction negation R, right? So therefore the answer for this is this P conditional to Q conjunction R is equal to P conjunction negation of Q disjunction negation R. That's it. This is the answer, okay? Listen, very simple. Let me explain. So what is to negate? Negation of P conditional to Q conjunction R. That is, just put the symbol for negation of P conditional to Q conjunction R. So there is a rule, negation of P conjunction to Q is logically equivalent to P conjunction negation Q. So P is as it is, this conditional becomes conjunction, negation of Q is nothing but Q conjunction R. So P conjunction using De Morgan's law. So that is using De Morgan's law. Then this negation of Q conjunction R becomes negation Q, conjunction becomes disjunction negation R. So therefore P conditional to Q conjunction R is nothing but P conjunction negation Q disjunction negation R. That's it. Followed. We want to a similar type problem. What is the problem given? Negate the following. So we have to negate this. First write down the symbol for this. What is the negation for this? Is negation of P disjunction negation Q. Now using De Morgan's law, this can be written as negation of P, disjunction will convert into negation of negation Q, right? So this is equal to negation P as it is conjunction. Negation of a negation, that is always equal to Q. So this becomes Q, right? So negation of P conjunction Q, right? So what is the conclusion? Therefore, negation of P disjunction negation Q is equal to negation of P conjunction negation Q. That's it. Followed? Okay. Now move on to the next problem. Negate the following proposition. Negation. This is very simple. Negation of P conditional to Q. So negation of this negation P conditional to Q. Now you know the rule for this. That is negation of P conditional to Q is logically equivalent to, this is logically equivalent to P conjunction negation Q, right? The same concept is used for this problem. So that is nothing but this is equal to negation of P conditional becomes, this becomes conjunction negation Q. That's it. Negation of P conjunction negation Q. Okay. Now move on to the next problem. What is the problem? Here negate the following. So a verbal statement is given. So we have to negate this verbal statement. This is also very important for 2 marks. 4 is an even integer or 7 is a prime number. So these two are connected by R. R is nothing but disjunction. So this is P. P means 4 is an even integer. This is Q. Is 7 is a prime number. So here this is given by P disjunction Q. Now we have to negate this. So therefore negation of P disjunction Q is equal to negation P and disjunction becomes conjunction Q. Negation of P conjunction Q. So this can be written as negation of P means, what is negation of P? 4 is not an even integer. Even integer. 4 is not an even integer, and conjunction or becomes and 7 is not a prime number. 7 is not a prime number. That's it. So this is the negation. So what is the negation? 4 is not an even integer and 7 is not a prime number. That is negation of P conjunction negation Q. Write the negation for this instead of for write and, again negation for this. Negation of P and negation of Q, that is 4 is not an even integer and 7 is not a prime number. That's it. Very simple. Okay. Now move on to the next problem. Second problem. If triangles are similar, then their areas are equal. So this is P, then their areas are equal. That is Q. So what is given? So this if then means that is nothing but a conditional statement. So the given statement is P conditional to Q. Now we have to negate. Negation of P conditional to Q. So what is negation of P conditional to Q? You know negation of P conditional to Q is nothing but P conjunction negation Q, right? P conjunction negation Q. Now what is this? This is nothing but P. What is P? P is nothing but two triangles are similar and conjunction mean and their areas are, negation of Q means not equal, and their areas are not equal. That's it. Two triangles are similar and their areas are not equal. So P conjunction negation Q is the negation for P conditional to Q. So this is also an important problem for 2 marks. So you may expect this type of questions for 2 marks, right? Hope you followed. That's all regarding today's session. Let us meet with the different concept in the next session. Thank you. Thank you very much.